Hi, I'm Granny, and we're going down the rabbit hole of the light spectrum and black holes. In our last episode, we learned about kelvins and joules, not the kind that you hang on your body, and how scientists are able to determine the chemical composition of stars using spectroscopy. I also have to make a correction because I misspoke in the last episode, using the word proteins instead of protons. So it should have gone similarly like this. The modern periodic table lists elements in the order of increasing atomic number, the number of protons in the nucleus of an atom. So today we're going to talk about black holes. Do you think scientists can see black holes? We've talked about the light spectrum, how if it was from San Diego to New York City, we would only be able to see like a yard. So there's a lot on the spectrum that we cannot see. For instance, my magnet, think about my magnet. So, two magnets. So, can you see the power between these magnets? No. But the power is still there. Even though you can probably put a finger through there, whatever, a piece of paper, I can feel the strength of the magnets, but I can't see it. All right, so in the journal Nature, October 2022, they talked about the phenomenon, which is known as precession and is similar to the wobbling motion sometimes seen in a spinning top as it slows down. Remember the Chandler wobble that we talked about with the light spectrum and the auroras? Well, this same wobble occurred when two ancient black holes crashed together and merged into one. And quoting from this Nature article, as the two massive objects swirled closer together, they released enormous ripples through the fabric of space-time known as gravitational waves, which surged outwards across the cosmos, carrying energy and angular momentum away from the merging black holes. The closest thing on earth that I can describe that to is if you a still pond or a bowl of water and dropping something in it and those ripples. Well, we're talking massive. So they're going to be discussing in that article in Nature millions and tens of billions of solar masses, describing how much energy was involved. Think of our sun, and that is one mass, solar mass, one. All right, black holes can't be seen. They do not emit light, but astronomers detect them through both the gravitational effects they have on other objects. Some supermassive black holes astronomers can see because of the quasars that they produce. And I want you to look at a quasar. Now, you've heard of quasi. So a quasar is a combination of the term quasi, sort of, and star-like, stellar, quasi-stellar. And so a quasar is that quasi-star-like, but it isn't a star. It's a radio source. Remember on the light spectrum, radio waves were included. So you can hear radio waves sometimes, but you can't see them. A quasar is an extremely luminous, active galactic nucleus powered by a supermassive black hole. And here we go. Let's think of our sun, one solar mass. So when they're referring to super black hole, they're describing it with a mass ranging from millions to tens of billions solar masses. That's suns. Tens of billions of solar masses surrounded by a gaseous accretion disk. And when you look at a quasar, know that that quasar is a result of a black hole. The gas in the disk falling towards the black hole heats up because of the friction and releases energy in the form of, and you're going to hear this phrase again because we've mentioned it, of electromagnetic radiation. All right, a year after Albert Einstein published his theory of relativity in 1915, Karl Schwarzschild, a German physicist and astronomer, developed the first modern solution that characterized a black hole. Scientists first detected waves emanating from black holes in only 2020, which means the theory that Albert Einstein came up with was 106 years previous to our scientists being able to detect the waves emanating from black holes. So in 2020, the Laser Interferometer Gravitational Wave Observatory, or LIGO in the United States, and Virgo gravitational wave sensors in Italy are what are the telescopes that, or the technology used in recognizing those gravitational waves. After years of studying the wave patterns, researchers have confirmed that one of the black holes was rotating madly to a degree never seen before. So it was those gravitational waves that the scientists could see to understand how crazily fast that the black holes were spinning. And that black hole, the spinning black hole, was twisting and turning 10 billion times faster than any previously observed black hole. That is mind-blowing, which distorted, according to this article, space and time so much that it caused black holes to wobble or precess, Chandler wobble, in their orbits. Researchers have observed precession or wobbles in everything from spinny tops to dying star systems, but never an object as enormous as a binary black hole system. Two black holes merging, in which the two cosmic vacuum cleaners, orbit around a common center. So when they use that terminology, vacuum cleaner, cosmic vacuum cleaner, it makes me wonder if one end is sucking stuff in, what happens on the other side? Anyway, Einstein's theory of relativity predicted more than 100 years ago that precession should occur in objects as large as binary black holes. Now, the study authors say this rare phenomenon has been observed for the first time. Quoting co-author of this study, Charlie Hoy, at the time of the study, he was a researcher at Cardiff University and then is now at Portsmouth in the UK. Quoting him, the larger black hole in this binary, which was about 40 times more massive than our sun, was spinning almost as fast as physically possible. Our current models of how binaries form suggest this one was extremely rare, maybe 1 in 1,000 event. Or it could be a sign that our models need to change. So, recently I came across an article that said that in the center of our universe or galaxy, the Milky Way has a black hole been discovered, and they've named it Sagittarius A. The Event Horizon Telescope took a picture of Sagittarius A. It is invisible, but for the gas surrounding it, which is how they recognized it. The stars near the center of the galaxy give off this gas, which is then drawn in toward the black hole like a vacuum. When the scientists study the flickering of this gas, they can see the changes in the amount of light emitted from this gas. So I want you to keep an eye out for more information on black holes. But I also want you to go down the rabbit hole of lasers. They are so fascinating. So also because a laser is a device of electromagnetic radiation. And lasers are used for so many things. So, have you ever heard of circadian rhythm? Is it a dance? Well, next time we are going to learn about our eyes and how they affect the circadian rhythm. Please subscribe and share and join me again for another episode of Granny Goes Down the Rabbit Hole when we learn about our eyes and circadian rhythm. Thank you.